This is a video of the surface of the Sun taken by a NASA telescope. But what's that strange black line moving across the image? If a piece of your data is showing something that shouldn't actually be occurring, you may be dealing with a data artifact. The different sources of data that we use for visualization can produce different kinds of data artifacts. Observational data, collected with sensors, for instance, is susceptible to interference, noise, and other errors. In addition to the telescope that captured this image, there's another measuring instrument on the satellite called a slit spectrometer that looks at one slit of the image, making it unavailable to the telescope and resulting in a black line. This is an artifact that's a result of the collection instrument, and isn't something that's actually happening on the surface of the Sun. Data that is simulated and not collected isn't susceptible to these same types of collection errors, but can still produce data artifacts. Sometimes, these can be the result of an error in the scientific simulation, or a mistake made during the data processing step. In this early draft of a visualization, we see a seam in this volume. This artifact is caused by an error in translating the data from spherical to Cartesian coordinates. On a circle, 0 degrees and 360 degrees refer to the same position. That wasn't accounted for here, so there's an overlap at the 360-degree line. It can be easy to spot errors in data once it's visualized. Visualization is often used as a tool for analysis and validation of scientific models. Scientists may visualize their data just to make sure that their math is correct, and these visualizations may not ever be published or shared with anyone else. This is why scientific visualization software like ParaView, Visit, and YT are popular. Scientists can get an image quickly without having to twiddle settings. Some things that may seem like artifacts, though, aren't mistakes or errors at all. This video of a solar flare on the Sun is missing an important piece: the Sun. How could scientists have forgotten to collect data on the Sun? That's not what happened here. This instrument was specifically designed to only study the Sun's corona, by creating an artificial solar eclipse that blocks out the Sun itself. The corona is often much more dim than the body of the Sun, so it's beneficial to block it out so that its brightness wouldn't interfere with what's actually being studied here. Scientists often focus their studies on one small piece of a whole. So to an outsider, it might appear that data is missing from their observations or simulations, when in fact it was left out intentionally because it simply wasn't being studied. The scientist that gave us data for this visualization of solar plasma engulfing the Earth didn't actually have the Earth in the data, since he was just studying what's happening around the Earth. You may find missing data in some datasets, but in others, you might find additional data that seems like it doesn't belong. The dataset behind this visualization of a protoplanetary system actually has a second ring floating above it. This was needed to make the simulation run properly, but the scientists told us that we should just ignore it because it wasn't physically accurate. Regardless of whether or not the artifacts are errors or are intentional, they can often be distracting and can look strange in a visualization, so you may want to take steps towards hiding or minimizing them. Sometimes you can hide artifacts like this extra ring with thresholding or with a clever transfer function, for example by setting the density value low to make it transparent. If the artifact is small and say occurs in just one or a few frames of your visualization, you may be able to remove it from your rendered images in a tool like Photoshop. But manual fixes like this can be very time-consuming. And if you edit your scene or if the error comes up again somewhere else, you'll have to redo the manual fixing. This is more of a last resort type of trick, as it can become very tedious, and it's often better to address the underlying problem rather than trying to patch it. If the artifact is an error in the model or in the data processing, you should rerun the simulation or the processing correctly, rather than just hiding the error, because the mistake may actually propagate to things that are not as visually apparent and give incorrect results. If there are gaps in the data, fill them in with context. If you can't cover or remove the artifact, you can just simply avoid pointing your camera at it. In cases where the artifact affects the entirety of the dataset, that may not be possible, but you may still be able to use clever camera tricks. In this example, the camera passes through a column of magnetic current just as the brightness changes across the whole dataset. making it so that the viewer can't tell that the data actually looks different before and after the transition. If you're trying to make a seamless, error-free animation, creative solutions are always welcome. Where you place your camera could really affect how your audience experiences your visualization. Something you may want to think about is whether to have your camera outside or inside the borders of your data, especially if it's a volumetric dataset. All datasets have borders or limitations because you can't simulate or collect the whole universe. The edges of the box aren't artifacts, but you may or may not want to hide them depending on your intended audience. If your primary audience is scientists, it can be beneficial to show the edges of the box so that they can see exactly what is and what isn't being studied. But if your audience is the general public, seeing the edges of a simulation that's supposed to represent the universe may be confusing and distracting from the narrative. Hiding the edges is especially a good idea if you're trying to make an immersive visualization. Some datasets are periodic, so you can actually tile multiple copies of the same dataset, and it will be continuous. You can put multiple data boxes together this way to fill more of the scene, but you don't want to show too many of them at once, or it will be obvious that they're tiled, which may also be confusing and distracting. Data artifacts can occur for a variety of reasons, and can at times be confusing to debug. But if you can find ways to remove them from your visualization, you can avoid passing on that confusion to your audience. This isn't exactly a fun fact, but here are some fun data artifact bloopers. Enjoy!